Hello, everyone, and welcome to today's webinar, Building AI-Enabled Digital Twins to Secure Your Supply Chain. We're excited you could join us. My name is Jennifer L.W. Fink, and I will be moderating today's event. Today, we'll be doing a deep dive into how biopharma companies can use artificial intelligence to establish resilient supply chains. Today, we are thrilled to be joined by Pari Sanghavi, the Managing Director for Life Sciences Supply Chain and Manufacturing Consulting at NTT DATA. Before we get started, I have just a few housekeeping items. Please note that the slides will advance automatically throughout the presentation. To enlarge the slides, click the Enlarge Slides button located in the right top corner of your presentation window. If you need technical assistance at any point, click on the Help widget located on the bottom left corner of your console. We encourage you to submit questions at any time throughout the presentation using the Q&A widget at the bottom of your console. We will try to answer these during the webcast, but if a fuller answer is needed or we run out of time, it will be answered later via email. Please know we do capture all questions. All right, to kick off, I would like to ask our speaker to give a quick introduction of himself and his work. Go ahead, Pari.
Thank you, Jennifer. Hello, everybody. I'm Pari Sanghavi. I'm the industry consulting leader for life sciences at NTT DATA. My background primarily consists of a mix of industry and consulting experience in life sciences operations across supply chain, manufacturing, quality, and regulatory. I focus on technology-driven innovations that can underpin digital transformations across the entire life sciences value chain for pharmaceuticals, biopharma, and medical devices. Lastly, I would like to call out that I do strongly believe in a future where semi-autonomous supply chains will not only be a reality for life sciences manufacturers and distributors, but where they may actually become table stakes just to stay competitive along the dueling dimensions of cost and customer service, which I'm sure are very near and dear to all of you.
Semi-autonomous supply chains becoming not just a reality, almost a necessity. Let's dive in, Pari. What recent factors have had the most significant impacts on life sciences supply chains?
So to begin with, we've had a unique set of needs for biopharmaceutical products and for medical devices all along, such as a need for higher safety stock levels for life-saving therapies. We have exacting quality criteria where a patient can die if you get the quality of the product wrong. You're generally working with delicate living cells in bioreactors for biopharmaceuticals. And you're dealing with multiple stages of manufacturing, such as API manufacturing, bulk, fill finish for pharmaceuticals, and a highly complex bill of materials for medical technology products. On top of that, when you factor in demand and supply fluctuations from things such as geopolitical events, extreme weather, as well as new product security regulations such as DSCSA for pharma or UDI for medical devices. We thus can't go back to the old ways of running our supply chains. We need to retool and reconfigure both the supply chain network as well as the supporting technologies that underpin that network. And we need to continuously evolve to get prepared for new personalized therapies, such as cell and gene therapies that require significantly colder cryogenic storage conditions, a batch size of 1 unit, speedy logistics, and a heightened need for real-time tracking. So for example, if you lose a product, you may lose the patient.
So challenging for supply chain to begin with, additional complexity due to environmental challenges, geopolitical challenges, the evolving nature of the business. So given all that has already happened, what kind of steps have life science companies taken to this point to secure their supply chains?
So supply chains today in life sciences are a hybrid of global, regional, and local supply chain networks. This is driven primarily by the product segment that supply chain network is serving. So, for example, for small molecules, it's typically a global supply chain where components are getting manufactured anywhere around the world and then getting assembled together. The second option is regional for large and complex molecules. And the third option is local, sometimes where it's driven by regulations, where in certain countries you're required to package the product in that country, irrespective of where it was manufactured. So, Gartner's survey from late last year indicates that life sciences manufacturers have already started evolving their physical supply chain networks. And to adapt to these evolving conditions, the primary vectors include diversity of both suppliers and manufacturing locales. A popular move, as an example, is de-risking your China-based supply.
Mm.
Another vector for introducing change is the localization of supply, moving your manufacturing closer to the point of consumption. And lastly, you're introducing supply risk and sustainability as additional input criteria when doing inventory optimization or when designing your supply chain network. So in addition to the physical supply chain network changes that we're in the midst of a wave of, we're also seeing technology-driven supply chain transformation initiatives that incorporate supply chain control towers or digital twins. And the most successful ones amongst these holistically take into account people, process, and technology. And they actively leverage AI and ML, which is artificial intelligence and machine learning based capabilities, into both their real time decision making and strategic decision making approaches.
So companies are already taking various steps in an attempt to secure their supply chains and ensure that they have what they need and they can deliver their products. What do you see happening to life sciences companies that are a little slower on this uptake?
So, the first point to note is that the supply chain trends and impacts that we just talked about are expected to continue increasing in both frequency and magnitude. And the next iteration that of something like we recently had with the pandemic could potentially end up being even more consequential. And some of these evolutionary changes that we've just touched upon, both physical
Mhm.
and digital, which are needed to make life sciences supply chains more resilient, will in time become an existential risk if not implemented soon and successfully.
It is a cliche, you snooze, you lose, but that's essentially what we're talking about here.
Exactly. Yep.
So, how can companies mitigate that risk? You mentioned AI, you mentioned machine learning. Is it time to consider using AI and ML to secure supply chains?
Absolutely, that's a great question. And based on multiple surveys that have been done by leading research firms, coupled with our own intelligence from assessing and informally polling life sciences firms across our extensive client base, if your firm is not already deploying at a minimum functional specific control towers for improved supply chain visibility or even AI ML supported automation and decision making, you are already trailing behind your peers, unfortunately. And depending on the default operating stance of your supply chain and technology organizations, you may get rated amongst your peers either as a technology pioneer or an early adopter is the first option, or you may get categorized as a mainstream technology adopter where you're staying with the pack in the middle of the pack,
Mhm.
or you may be tagged as a supply chain technology laggard. And if you believe that you're in the technology laggard category, it's still not too late to rapidly start advancing into the mainstream category. But you need to start now, or you will have a much harder time catching up down the road due to longish cultural and behavioral adoption curves inherent in such digital transformations. As they say, there's a reason takes 9 months to go from a fertilized embryo to a newborn human child. Similarly, you're not
Mm,
going to get a digital supply chain twin overnight.
this is not something that I can just go pick off the shelf, plug in and play, and it's all set up.
Correct.
So,
Yes.
what you said may be disturbing to some. If you're not already doing this, you are falling behind. Um, let's take a moment, step back, and define a few terms here to make sure that we're all talking about the same thing. So you mentioned control towers. What is a control tower? And then how does that fit into this digital twin concept?
Yep, great question. And it's important to level set since there's a lot of industry terminology and lingo and jargon going around. We all need to standardize, and it is generally standardized if you're tapped into some of these developments. So let's first define and explain the concepts behind the generic digital twin. And then we'll take a shot at better explaining traditional supply chain visibility control towers. Both of these are terms that you've probably already heard of. And then we can finally start to draw out some parallels and differences between the two. This will effectively give us a holistic understanding of what an intelligent digital supply chain twin can enable today. So let's start with a digital twin. Let's look at, say, Gartner's definition of a digital twin. They define it as a technology-enabled proxy that mirrors the state of a physical thing. Now, a thing here could be an asset within a factory, could be a customer, could be a product being used by customers, such as a medical device, or it could even be an entire supply chain organization. And to better understand, what a digital twin is, I'll give you some common examples of digital twins that you're probably already using today or have seen already. So the first one is used in the industry. It's the picture you're seeing is a digital twin of a gas turbine. GE has built a virtual digital twin of their gas turbine. Very critical for power generation, hydrothermal, and geothermal plants. And the second example is something that you all use on a daily basis. You may use a different mapping software, but everyone uses mapping software to get anywhere nowadays. And it may be surprising to you to learn that this mapping software is also a digital twin. And the reason it's a digital twin is because it gives you predictive capabilities of what the traffic is going to be in the future. You can actually adjust the departure time or arrival time, and it'll predict what the traffic is going to be. That's an intelligent digital twin of the traffic situation around you. And the last is a semi-autonomous, or some may even call it fully autonomous car, example Tesla, which has a visual view of all of the different moving parts around you. So that's another example of a much more sophisticated digital twin. So those are examples of a digital twin. If we look at a supply chain visibility control tower, on the other hand, as a concept, it has been around for a long time. And the origin of the term started in the quintessential airport control tower that we've all seen, and some of us may have even had a chance to visit. What's unique about its design for an airport control tower is its curved 360-degree shape and the way the windows slope downwards. This is simply to provide a better real-time visibility for all the airplanes on the taxiways and runways of the airport. Now, if you put that in a supply chain context, a supply chain control tower's primary purpose is real-time or near real-time granular visibility into parts of your supply chain. Most control towers excel at providing this visibility, but they traditionally do so only for a specific facet of your supply chain, such as for your suppliers and POs, or last-mile logistics to your customers, or just to name a couple of popular use cases, your logistics warehouse or your manufacturing facility. These are all function-specific control towers that already exist today. However, these control towers typically struggle to incorporate meaningful intelligence into their solutions, as they don't necessarily yet have full end-to-end visibility across the entire supply chain. And if we quickly fast forward to today's AI-led age that we now live in, where we can do true end-to-end supply chain visibility, you're already seeing that with things such as Spotify and Netflix, where the recommendation engine, which is AI-driven, is recommending things to you. Why can't we have a similar recommendation engine for your supply chain, which is recommending what the risks are and how you should mitigate those risks, how you should plan, how you should execute, all in real time using granular data? That's the future that is possible with digital twins.
Those examples are so helpful to me and probably others too. When you say digital twin, it's this big concept. When you say, Google Maps, yes, the Spotify, the Netflix algorithm, and how those are making recommendations based on real time data, that makes it a little bit easier to think about the possibilities for supply chain. So let me ask you this. Is this something that already exists? Do digital twins already exist today in life sciences?
Yep, you'll be surprised to hear that several clients that we work with in life sciences have already deployed pockets of supply chain visibility at scale. Many of them are additionally using real-time logistics and transportation data, coupled with AI-based supplier risk scores and demand sensing, to provide instant decision support prompts for the supply chain planner. And this has demonstrably increased supply chain resilience. It's optimized inventory levels further, and it's reduced their overall cost to serve while also improving customer service levels. It may sound like futuristic and magic, but it's there today.
So, a few companies, at least, are already seeing the benefits of applying AI to supply chain management. Clearly, there's a ways to go. There's a lot of room for growth and potential. Future projecting. How do you think digital twins will evolve and ultimately help life sciences and pharmaceutical companies secure their supply chains?
Yep, to answer that, I'll start with a real world personal example of how I've seen digital twins and AI evolving over the last decade or so. I've been enjoying Tesla's self-driving capabilities now for over 3 years. In fact, the first time I started to take advantage of a rudimentary form of semi-autonomous driving capabilities was about 17 years ago on my first Acura. It had dynamic cruise control, which essentially maintains a constant following distance between your car and the car ahead of you. And it does this by autonomously slowing down or speeding up. That was an example of a rudimentary form of an intelligent digital twin, as it also varies the distance and the speed, and it will also brake hard to avoid a collision, all significant execution steps. Now, if you look at the current state of AI and intelligent digital twins deployments into life sciences supply chains, I would say that we're somewhat comparable to that first rudimentary iteration of this digital twin capability that I saw in my Acura 17 years ago. Looking forward, if we look at how far dynamic AI-based digital twin intelligence has advanced today in the automotive world, where you as a driver on the roads are comfortable enough sharing the highway with an AI-driven car, while also materially reducing the risk of an accident, thanks to superior safety profiles of that very same AI, there is every reason to confidently imagine and embrace a future where your supply chain essentially runs itself much better with a little bit of light supervision from you, the human.
That's exciting. I mean, you're talking about a future in which, after setting this all up, which of course does take effort and time, but after getting it all set up, it can do better and more efficiently. Something that right now is kind of laborious and too unpredictable.
Exactly. Yep. It's a given that it's going to do it better than the human. It's just a matter of how quickly can you get there and what do you need to do to get there.
So it sounds as if waiting for somebody else to do this or waiting for it to happen is the wrong step. But getting started can be scary too. What does a company need to begin creating a digital twin? How does one begin this process?
Yep. So what I've tried to capture here are a few building blocks that are needed, or you can consider as the key ingredients for a digital twin to come into existence in your organization. So I'll start with inventory of the existing data. So you need to inventory your existing data. You need to take stock of all of the supply chain related data that's already being made available for you by your intelligence layer. Typical examples of already available data in your organization will be things like demand forecast, customer order data, distribution and transportation data. real-time inventory data, purchase orders, and production orders. These are all examples of
Okay.
things that are typically available. The next thing you need to do is you need to harmonize all of that data that's being sourced from disparate systems. And if there are gaps in your harmonization, or if you're unsure whether you have gaps, you can always leverage our transformational data readiness assessment and scorecard that will help you quickly identify inherent data and harmonization issues and provide you recommendations to rapidly address them. The
So
next
you're
step
saying
is, yeah.
you're saying there's tools available that can help you figure out where there might be some issues and suggest some tools to remediate that.
Yes, exactly.
Okay.
We have tools that can help you do that. Yes.
Okay.
Uh,
What
the, the
else?
next, yep. The third bullet down here is to ideate, prioritize, and select use cases. So, you need to start identifying your biggest yet solvable pain points, and you need to start mapping them to prioritize use cases, and you need to select those use cases from out of a robust set of use cases that are either already proven by industry pioneers or that have shown significant initial success when piloted. And we have just such a list that we work with customers to tailor for their specific needs. Examples of such proven use cases include AI-based demand sensing and forecasting, predictive maintenance of your equipment, risk management and resilience of your supply chain, route optimization for transportation, logistics orchestration, just to name a few. And another approach you can use to narrow down your use case list is to develop an end-to-end mapping of your planning process where you're including all key inputs and outputs, and then identify points in the process that are most reliant on human expertise, but where data already exists, and target those use cases first.
Ah,
Start with simpler use cases such as demand forecasting or demand sensing first to quickly start showing value from your AI, ML, and digital twin initiatives. Additionally, at this initial stage of your journey, aim to limit yourself to already available and harmonized data rather than trying to source and harmonize across all possible data sets. This will essentially limit the risk of your nascent AI initiative. It'll improve the probability of a quick win to help gain some momentum. And it'll also promote buy in from naysayers across your organization.
that's so important. Finding a specific area where you may be able to make a difference relatively quickly, get a quick win, and then people can see how this will benefit an organization. So the starting point is data and visibility. What else do companies need to construct a digital twin?
Yep, starting point, as you said, is data, visibility, and use cases. What more you need on top of that is you need to clearly define your data fabric and AI technology stack. Data fabric is just a fancy term that's been recently introduced that's meant to represent the data architecture and schema for all of your data. Where is it going to get sourced from? Where is it going to get stored? How is it going to get refreshed? How granular is it going to be? How is it going to get harmonized? All of those different dimensions around your data, when put together, become the data fabric. They stitch all of your data together into one seamless fabric that you can wrap around your solutions and consume the data from that data fabric. So it's important to set up your define and set up your data fabric and AI technology stack. Your AI technology stack in itself will also have a bunch of tools that you need to make sure are enabled and integrated with each other and working seamlessly for you to be able to stand up your digital twin. The next is the people itself who are going to be standing up that digital twin and using that digital twin. You need to upskill them and grow their digital IQ, if you may. You can do this by partnering with internal or external data science experts, drawing on their knowledge and experience to identify the clearest opportunities to improve supply chain planning performance. And don't ever neglect investing in building your planner skills, confidence, and technology acceptance and adoptions, right? You need that
Yeah.
software change management angle as well, in addition to upskilling them digitally. And last but not least is to define the operating framework. As part of your piloting stage, you also need to start thinking about things such as the long-term organizational impact of deploying these new capabilities at scale into your organization. You will come across questions such as Will the AI engine be initially used as a decision support system to simply augment the human? Or will simple actions be implemented as fully autonomous actions automatically executed by your newly acquired silicon based intelligence? Will a
Mm.
human initially intervene to review and approve every action, no matter how simple? Well, we strongly recommend that this safeguard be in place until you have enough history on the consistency and accuracy of your intelligent digital twins decision making capabilities. We will dive deeper into this topic later in this webinar for sure, Jennifer.
That is helpful and a lot of information to take in. This is not as simple as just gathering up some building blocks and then putting them all together. These are complex. Each of these steps takes significant effort. And that's all embedded within company culture, within company strategy. So what role does that play? What role does company culture and strategy play in creating digital twins and intelligent supply chains?
Yep, yeah, never ignore the softer aspects and never ignore the ultimate goal, which is to enhance your business and operate it optimally. So let's start with culture change, right? Many organizations have a culture of if it ain't broken, don't touch it. And that
Yeah.
can be a major issue if this attitude exists at the leadership level. Luckily, most senior leaders in most organizations today have already been issued marching orders to significantly expand the use of AI across all business functions, and supply chain is no exception. Identifying and securing sponsorship at the senior most levels is critical for successfully kicking off or maturing your intelligent digital supply chain twin initiative. And don't forget, it's only a means to an end. Deploying AI or building out an intelligent digital supply chain twin should never be your ultimate objective. Your ultimate objective should always be the enterprise level business objectives, as typically already defined by your chief supply chain officer, chief operating officer, or chief executive officer. And leveraging an intelligent digital supply chain twin is simply a means for achieving such business objectives that have been defined by your senior most leaders.
So even though we are talking today about building digital twins, that is not the objective. It's really creating a sophisticated tool that can be used to achieve company objectives.
Absolutely. Yep. It's all about advancing the business's goals. Yep.
So within a business, there can be various levels of goals. So how can a digital twin help companies integrate and advance both business goals, overall strategy, and manufacturing goals?
Yep. So we have a framework that we use with our clients for just exactly that. It starts with the definition, baselining, and remeasuring of all your KPIs. So your enterprise level business objectives need to first get mapped to specific KPIs and metrics, which when improved will prove the success of the use case beyond dispute. Next, you need to measure them and establish a baseline if one doesn't already exist. And lastly, you need to define what success looks like upfront. You need to establish a milestone-based plan for periodically remeasuring your KPIs and metrics against the predefined improvement targets, which you would have set upfront. So that's around your KPIs. Next, you need to think cross-functionally. While the initial set of use cases chosen should intentionally be simpler and faster to bring to fruition, you also need to think outside of your traditional functional or sub-functional silos. And the reason you should be doing that is because cross-functional use cases generally deliver much higher levels of business value. As an example, if you're able to replan your supply chain on the fly using real-time AI-based demand sensing, you will realize benefits both in terms of improved customer satisfaction and lower inventory carrying costs. Who wouldn't want both of those benefits together?
Yeah.
Next up, you want to make sure you don't trivialize OCM. We talked about it a little bit earlier. For most life sciences firms, technology is typically used as an enabler of business processes that are then executed by employees who are part of a large and complex organization. The old adage of addressing people, process, and technology simultaneously is further amplified when deploying transformative technologies such as AI-driven intelligent digital supply chain twins. And additionally, adequate training on underlying data and automation technologies, process retraining, SOP updates, and org design or org redesign are just some of the many dimensions that need to be tackled when embarking on such AI-driven journeys for your supply chain. And last but not least, remember it's a journey. It's critical that your first few AI-driven use cases are successful in order to be assured of long-term support across your organization. Structure your business case and roadmap such that the business value delivered by the first few successful use cases is captured and reused towards the continuation of this very initiative. You're thus essentially making it a self-funded business case after the initial one-time funding. Who wouldn't want that?
Self-funded sounds very attractive because, of course, concern for the cost is always an issue. Nobody wants their business to fall behind, and yet financial constraints are very real. So that's one potential obstacle that we have addressed. You proactively mentioned that one, but certainly there are others. What are some of the logistical and operational hurdles that have kept companies from moving forward and are keeping them from moving forward with smart supply chains?
Yep. So it's a perfect segue to, how to make sure you are not blindsided as you kick off your initiative. So every one of the functional building blocks that we outlined in the previous slide can be a potential obstacle if not addressed upfront. Let's take a closer look at some of the common derailers faced by firms that are either just starting off on this journey or that have already begun their journey, but are having difficulty gaining widespread adoption at scale. So I'll address both of those camps. Without a robust strategy and approach for your data fabric, your disparate initiatives are unlikely to ever converge, and you will have difficulty realizing the full potential of cross-functional business value. That's number one. Number two, if you select incomplete data sets, you will not be able to bring your use cases to fruition. Next, you may happen to magically source all of the needed data for your use cases, but if you have not harmonized the data sourced from these different systems, you will take much longer to enable your digital twin. Next, if you choose your use cases that are overly complex or difficult in your initial target set, you may lose sponsorship before you even get off the ground. Next up is the digital skills within your IT or within your supply chain business function. You will face significant resistance to change as ignorance-driven fears of workforce reductions take hold. Everyone starts to think, I don't understand this technology. Is it going to eliminate my job? So you definitely want to make sure that you're adequately upskilling the digital skills of your organization. Next up is the governance framework. Without an adequate governance framework, you may end up with significant data and AI technology diversity and potentially redundant capabilities. And lastly, the best means of overcoming resistance to change is to secure upfront sufficient championship and sponsorship of your initiatives, both from senior business leaders within IT and from within the supply chain organization. For firms that are already well down the journey of introducing digital twins or AI into their supply chain planning and operations, they're likely to find themselves running into an entirely different set of challenges. These challenges can be mitigated proactively if anticipated and addressed before they become an issue. A couple of prevalent challenges are proving the initial business values. Another one is scaling out your MVPs and pilots to additional segments of your supply chain. And the third one is democratizing the innovation process whilst still keeping it well governed. So these are all common challenges that the latter camp that's already kicked off their initiatives may run into.
So obviously, each of these challenges requires a slightly different response. So, if the issue is insufficient championship, that's where you need to target it. You need more senior leadership on board championing it. If it's lack of digital skills, you need to provide additional support and training. But broad scale, how can companies kind of proactively mitigate these challenges to set themselves up for success?
Yeah, so if you miss on any one of these challenges, you're going to have significant issues. So you can't, none of them are optional. That being said, to address your question more directly, first and foremost, as a life sciences manufacturing firm, you need to clearly document an internally aligned vision and roadmap of your supply chain digital twin. The roadmap needs to clearly depict both your desired long-term end state as well as how you're going to get there. These will, of course, change over the course of time, but you at least need a starting point to anchor off of. Once you've selected your initial set of use cases, you then need to map them back to the data needed to achieve those use cases. On occasion, you may choose to flip this around and choose a use case that aligns well with the data that's already available and harmonized. It doesn't matter as long as you're tying your initial set of use cases to the underlying data needed to bring them to life. The next step you'll have to take is to work with your IT organization to learn about your data fabric and AI technology stack and actively extend those core technologies and data into the supply chain organization. This step will ideally also address the upskilling aspects of your supply chain org. And last but not least, you will very often find that digital twin deployments don't happen in a linear and controlled fashion, especially in large organizations. There will likely be siloed pockets of experimentation happening across different subfunctions and geographies. They will all need to be brought together, at least loosely, under a common governance umbrella.
This is very complex. And yet, we've already clearly established that the risk of not taking steps in this direction is pretty great. It's a major risk of falling behind within the industry, of not having a reliable supply chain. And yet, with all of the competing issues requiring attention from senior leadership, from everybody within the company, how can companies start weighing out the risk versus the benefit of beginning to invest in intelligent supply chain development at this time?
Yep, I'll start with a statement that may surprise some of you. So the fact of the matter is that the majority of the life sciences firms have already started to prove out pockets of AI and digital twin capabilities within specific subfunctions of their supply chain. Given this fact, the primary decision that you may need to take is how rapidly should you progress your supply chain digital twin initiative and not whether you should kick it off in the first place, right? I don't think that is a decision anymore. The decision of that you need to kick it off has already passed. That ship has sailed. You have to kick it off.
It's been made for you.
Exactly. The majority of firms have already kicked it off. If you're a part of a large firm or one that has a healthy risk appetite, and if you're looking for a supply chain driven competitive advantage, you may want to have multiple pilots in progress at any given time. You may also want to couple that with scaling out already proven use cases. If, on the other hand, you simply want to keep up with evolving digital twin and AI trends in supply chain, you may instead want to wait for your COTS solution providers. COTS here stands for customizable off-the-shelf software. So you may want to wait for your COTS solution providers for supply chain planning platforms and control towers to gradually roll out AI-based capabilities. And you don't experiment outside of the published capability roadmaps of these solutions. So you have both of these approaches you can take. You can either wait for the solution providers to start introducing these capabilities into their solutions, or you can start doing it yourself by piloting, proving out, and scaling use cases yourself.
How are AI and intelligent digital twins, how are they typically introduced into an organization?
So supply chain digital twins can start from any of these inception points that you're seeing here. So, and these are all very interesting examples of how organizations are using digital twins and AI today. So I'll take a couple of minutes to explain each one of these for you. I'll break them down for you. So let's start with the supply chain network design tool. So before you even have a supply chain network, you have to have some idea of how you want to design and set up your supply chain network. Where should you set up your manufacturing facilities? How many manufacturing facilities do you need? Same for your warehouses and routes and so on. So supply chain network design tool, by its very nature, Examples are Llamasoft, and we at NTT Data have our own supply chain network design tools, which comes to us from analytics, Chainalytics, which we acquired. So both of these are examples of a digital twin that already exists today, right? When you're doing supply chain network design, you're doing it based on a digital twin representation of your actual supply chain. Another example is control towers that we talked about. Function-specific control towers already exist as COTS or SaaS-based solutions today. Examples are SERIS technologies for supplier risk management and alerting. You've got manufacturing control towers, which can take the form of IIoT platforms. You've got transportation control towers like Project 44 and 4Kites, which in addition to providing transportation visibility, also integrate into your transportation management systems. And they also give predictive capabilities of when your shipment is going to arrive, and you can use that information to tweak your execution or planning decisions. The third place where we see it happening or taking place is the digital twin of the customer. And you may have heard of this in the form of demand sensing, where in order to do better demand forecasts, instead of just using historical data and a few parameters tweaked here and there, you're actually predicting demand based on the sensing of factors that influence demand. And nothing better than taking that a step further and creating a digital twin of the customer. So with the digital twin of the customer, you're essentially trying to imagine how the customer is going to think when you introduce certain events into the picture. So take as an example, when we had the pandemic, we all read stories about, and we saw it firsthand as well, of how toilet paper started running out. That's an example of the customer's mindset taking a different twist, where there was no sudden reduction in supply of paper towels, but customers sensed that there could be a reduction, and they went and stockpiled.
Bottom up.
Paper towels and bathroom towels. So, if you're able to think like the customer by creating a digital twin of the customer, you're a step ahead of the game already. The next one is the supply chain command center. This became popular in the life sciences world and in other industries as well as a result of the pandemic. So, what does the supply chain command center do? You may have all seen command centers of, say, a train transportation network, where you have a bunch of monitors and you're seeing all the real-time status of everything in that network. Similarly, for a supply chain, you may have multiple control towers that are function-specific: supplier, manufacturing, transportation, logistics, etc. When you patch all of those different disparate functional control tower capabilities and visibility into one cohesive view, which may be across different monitors or maybe patched together into one monitor, you are essentially taking the first steps towards response planning, where you're actually able to detect alerts and events before they happen or as they happen, and you're able to effectively respond to them. And then the last option where we see that point of inception is a supply chain planning platform. The likes of O9 is a digital native supply chain planning tool that has AI built into it. And that's another path that you could take, where you're receiving data from other sources into your supply chain planning platform, and you're using rudimentary AI within that planning platform to make better optimal planning decisions based on evolving data.
So there's a variety of inception points, and I imagine that where a company chooses to start depends on their needs, the data that already exists, et cetera, to get to that future that you mentioned earlier of a semi-autonomous supply chain. It will require a lot of these pieces and parts coming together, correct?
Yes, that's right. Absolutely.
So how do you keep all of these disparate initiatives aligned and in sync? Because if this piece doesn't work over here, I'm not going to get my semi-autonomous supply chain.
Yes. So those of you who've been paying attention to the webinar so far, as you'll remember, we said a robust governance approach is a critical step to take, and can be an obstacle if not taken. So that's a critical thing that I'll point out here. You need to also couple that with the championship of your initiative from senior leaders. So, those two are key ingredients in keeping all of these disparate initiatives aligned with each other. and you don't want to stop it, right? You don't want to take a very authoritarian approach and say, I'm the only organization that's going to innovate around digital twins or AI. You need to allow innovation to organically proceed without stifling it. But you also have to keep things marching towards a common vision and end state of foreign intelligent, cross-functional, end-to-end digital twin of your supply chain.
Hmm. There's where you start, and then there's where you hope to end up. How do you see digital twins, control towers, intelligent supply chains evolving and maturing over time? There's what we can accomplish in 2024, 2025. Look further for us.
Yeah. So let's talk about the evolution maturation of these points of inception, right? So let's say you're at a point where you've started to enable pockets of digital twin capabilities within your supply chain at any of these inception points. You will quickly want to start tapping into various cross-functional use cases. Examples of such use cases, cross-functional use cases, could be, for example, using supplier risk predictions from a solution like Ceres to adjust your production schedule, or using predicted inbound shipment arrival data from solutions like Project 44 or FOCITES to better orchestrate your yard management and appointment scheduling for the arriving shipment if it's going to be delayed. You could also use updated demand forecasts to replan your supply on the fly. And lastly, you can use simulations to predict the impact of possible disruption events. These are just a handful. There are many more that we can go on about, but these cross-functional use cases are ripe for the picking once you've embarked on your journey, and will quickly start to bring your entire supply chain organization together once they see the power of being unleashed by these cross-functional use cases across pockets of visibility and intelligence and digital twinning.
That's the power, is that you're not restricted to one area. Now you get a much broader view. Things can communicate, and you can draw on all of this information.
Exactly, yeah.
We mentioned early on that building a digital twin is not the goal here. What is the desired ultimate end state, and how should clients go about charting a path towards such a long-term state?
Yep. So those of you who remember when I first introduced myself, I laid out a strong belief of mine, and I'll stick to that belief and I'll reiterate that belief, right? The ultimate desired end state that anyone should be aiming for should be nothing short of a semi-autonomous supply chain that practically runs itself. It's not going to happen overnight. And that's all the more reason that you need to start now and not be left behind your peers on this journey. You're only going to achieve it painstakingly, proving out and scaling individual use cases, which will have to be done over time. And you'll have to stitch these use cases together into a cohesive whole. So the journey is necessary. It's not overnight, but it's going to be rewarding from day one, and it's going to keep giving you rewards, which will self-sustain that journey towards a long-term vision of a semi-autonomous supply chain.
Thank you so much for sharing your expertise with us today, Pari. We have some questions, so let's shift to a couple of these. Let's start with this one. Who needs to be involved in the creation of a company's digital twin and intelligent supply chain? We talked about the importance of championship, but who are some of the people that critically need to be involved?
Yep. So the first is the functional leader for the supply chain function, where you're looking to introduce digital twins or AI capabilities. That function leader would be the primary driver. They would typically partner with the technology organization, and the technology organization in turn will have to bring multiple key players into the picture. They will need to bring the data architect who's going to make sure all the necessary data is there. They're going to have to bring in the AI specialists who are going to introduce the AI layer to train the machine learning neural network. You're going to have to bring in data scientists who can act as the glue between the data itself and the AI people who are coding your machine learning algorithms and so on. So you're going to need a variety of such multi-skilled individuals who are coming together with a common goal to help achieve what is going to be a very rewarding journey.
It's a team effort. Has to be a team effort.
Yeah.
I think we have time for one more. And this is interesting. How do you think future technology will affect the construction and management of intelligent supply chains?
Yeah, so that's a very great question, right? And it's something that I continue to stay abreast of and reflect on. So I see a couple of different paths to the evolution of future technology that is going to underpin all of this. It's going to keep getting better, right? Let's be very confident of that. Unless something drastic happens, not this technology wave is not going to get derailed. This AI and Gen AI technology wave is not going to get derailed. So you're going to see the evolution of digital twin-based intelligence, both within the cloud solution providers that we talked about, which can be on-prem or SaaS. And you're also going to see organizations that don't want to lock themselves into any one platform or solution to build their own intelligence layer that is actually stitching all of these pieces together. And so it's just a different approach, right? If you have a bigger risk appetite, if you have deeper pockets, and if you have a more pressing need because of scale and other drivers to accelerate your adoption of digital twins and AI into your supply chain, you may take the approach of not waiting for the solution providers to introduce AI capabilities over time. But on the flip side, if you don't have the scale or deep pockets or the supply chain optimization is not a priority, you may choose to wait until your solution providers have slowly started to introduce more and more AI capabilities and functions into the solutions. And that's not a bad approach either, right? There's no one right approach. The right approach depends on you and your specific situation. And that's where we come in as NTT Data Consulting to strategically advise our clients on the best path forward and what are the different criteria that should be leveraged and evaluated for determining that path forward.
Pari, I would like to thank you so much for this conversation today. This has been fascinating, enlightening, and useful. I so appreciate you sharing your insights and your expertise with us. And I would also like to thank our audience for joining us today. We hope to see you soon. Have a great day.
Thank you. Bye-bye.